Hey guys, welcome to, yes you guessed it, it's word problem time. So we're going to cover two major problems and that's it for 2.9, and then you will be taking a test just on word problems. So mixture problems are the ones we're going to talk about today, and these are going to be two different types, one that's about liquid things and one that's about dry things. So we're going to kind of use a formula to help us. And I'm going to actually split the formulas up onto the 2 pages. Actually, I'm going to say formula. So this is for dry ingredients. So dry mixtures. Oops, dry mixtures. So we've got amount, which is also known as quantity, so how much. We're going to multiply that by the cost of 1 unit, so like per pound or per ounce. So 1 unit of measurement. And then that's going to equal the total cost. And we're going to use this to help me set up a chart to help organize my data. Okay? So that's going to be the next thing I'm going to write. Use a chart to organize the data. And the great thing is, it does a couple different things. It will define the variable, and it creates the equation. So, twofold, really helpful. All right, so we're going to go ahead and write down the problem. I'm going to turn off my, I'm going to pause and I'm going to write it out because you really don't need to listen to me write it and talk about it at the same time, or talk it out. So I'll be back in a flash. Okay, so again, if you aren't going to write down these word problems, your notes are not going to make any sense. So the whole point is to connect the word problem with how we put it together, okay? So the directions ask us to define the unknown, translate an equation, then solve. How many pounds, and again, go ahead and you can pause it. How many pounds of premium coffee beans that sell for $9.50 per pound should be mixed with 2 pounds of supreme coffee that sells for $11.75 per pound to make a blend coffee that sells for $10 per pound? Okay, so what we have is 2 different types of coffee. We have premium coffee, we have supreme coffee, and they together make a blend coffee. So those are going to be listed in our chart going down vertically. Premium, go ahead, I'll just do these. Okay, then comes the supreme, and last is the blend. Okay, now what we're going to do at the top is we're going to be listing those words that I have in our formula. So, oops, I need to add another black line here. So we're going to have amount, and we're going to have cost per pound, and then we're going to have total cost. Okay, so now we go back and we look at that formula and we see some math going on. So we're going to take the amount, we're going to multiply it by the cost per pound in this particular problem because that's the label we have, and then equals. Okay, so depending upon what you're measuring in, that's what label goes on to that middle column: cost per ounce, cost per foot, cost per pound, so on and so forth. All right, now we're going to go back and see if we can figure out some information about the premium coffee beans. So it says how many pounds, so that's amount, so we don't know how many that is, so that's my x. So right then, I've just said that x represents the amount of premium coffee beans. Okay, so I've defined my variable in my chart. They sell for $9.50 per pound. So the total cost would be the product. Now, what I'm not going to do is include those zeros. So I'm just going to make it 9.5x. Now, Supreme, it says how much of the premium should be mixed with 2 pounds of Supreme coffee that sells for $11.75. So that's going to give me 2 times $11.75. And if I multiplied that out, that would give me $23.50. Now, for our purposes, we can not include that zero when we're setting up our equation. And then we're going to talk about the blend. So let's reason this out. If I'm combining or mixing premium and supreme to get the blend, I'm actually adding these together. So that's going to give me x plus 2 is the total amount I'll have in that blend. The beans don't like blend into each other like 2 beans making 1 bean. No, they just stay their separate beans, but the flavors are getting blended. And then it says that it costs $10, so I'm just going to write it like that. And then I get 10 times the quantity x plus 2. So if I'm trying to figure out how to write an equation, it's actually already written for me. And you might say, what you talking about, Willis? What you want to do is look in the total cost column. That is your equation. So we're going to write 9.5x plus 23.5 equals 10 times the quantity x plus 2. Okay? So we've got the cost of the premium is the 9.5. We've got the cost of the Supreme as $23.50. And then we have the cost of the blend being 10 times the quantity x plus 2. So I'm going to go ahead and distribute. So we get 9.5x plus 23.5 equals 10 times x and 10 times 2. Okay. Next thing is I don't really like dealing with fractions, so I'm going to multiply by whatever it takes to move the decimal points over all the way. And let's see, I have 1 digit after, 1 digit after, no digits after. So I'm just going to multiply everything by 10. This is why we talked about that earlier in the chapter. This is really when it comes into play. Well, in any kind of equation that has decimals or fractions, it just makes it so much easier. So now I'm at 95x plus 235 equals 100x plus 200. So again, I'm going to go ahead and get my variables on the left. I'm going to subtract 100x from both sides. Actually, let me go back. I'm going to use pink again. I'll just make pink the color of math today. And I want to get the constants together on the right, so I'm going to subtract 235 from both sides. So let's see, bigger number is negative, so I'm going to have a negative. 100 take away 95 is, 5. So we get negative 5x, he's gone, equals, bigger number is negative. 235 take away 200 is 35. Now, some things to think about. Generally speaking, if you get a negative answer, no, that's pretty much all the time, you're going to get a wrong answer. If you get a fraction or decimal answer, that may not always be positively good, so you might have to check that one out. Okay, so we get x equals 7. So then I'm going to write my final answer. It would take 7 pounds of premium coffee beans. Oh, yep, beans. Almost thought I was going to do 2 E's. To make the blend. Coffee. That's worth $10. Nah, which is, to me, I'm actually going to stop right there. I think that's good enough. It would take 7 pounds of premium coffee beans to make the blend coffee. And that's it. All right, I'm going to go to my next screen. So this should be the end of your first page. Second page, we're going to go ahead and come up again with another formula. But this time we're going to talk about liquid mixtures. Okay, so the formula is going to sound very similar to the one before, with the exception of we don't have cost when we're putting liquids together. Okay, so we're still going to start with amount, which is again the quantity, how much. So this time we're going to be hearing labels like liters or milliliters or gallons or quarts. Generally it's metric, to be honest with you, because it's more of a science question. Here's the big difference. We're going to talk about the percent of the solution. So we could have a salt solution, we could have a sugar solution, we could have an alcohol solution, iodine solution, milk fat solution. We have a lot of different solutions we can have. Now, the key is on this, we can't multiply by percents. We learned that back in 5th grade, 6th grade, and again, 7th grade, is you must change to a decimal. Now, none of these percents are going to be such that you would get a repeating decimal, so that's okay. And the answer is not going to be cost because there's no money in here, but it's going to be total amount. Okay, so let's see, what kind of problem do we have here? So again, I'm going to pause and I'm going to write down the problem and then come back. Okay, so again, we're going to define the variable, translate the equation, then solve. So this problem says one type of antifreeze is 40% glycol and another type of antifreeze is 60% glycol. How much of each kind of how much of each kind should be used to make 100 gallons of antifreeze? That is 48% glycol. So here I go telling you it's going to be mainly metrics, and then I throw in a gallons. No big deal. It's not going to be hurt you at all. All right. So go ahead and pause and copy down the problem, and when you're done, come on back and let's get started. All right. So we're going to look at what we have here in our chart. What we're going to do is write down the types of glycol that we have. So we have a 40% glycol solution. Let's see, another type is 60% glycol, and then we want to come up with something that is 48% glycol. Okay, let me get my lines in here for my table. Boop. 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 Voila. Okay, so our labels are going to be amount, and then percent of glycol, Now, one thing I notice when kids are using tables is they don't label the tables at the top, so actually your table doesn't mean anything. So without those labels, amount, percent of whatever, total amount, I don't really know what I'm looking at. So you got to label everything around the edges. So let's go back and let's see. All right, the ones that are easy to fit in are the percents. So 40% is going to become 0.4. 60% is going to become 0.6. And 48% is going to become 0.48. Okay, so we got that. And then let's go back and read to see if we can find something else. One type of antifreeze, 40% glycol. Another type of antifreeze is 60% glycol. How much of each kind? Ooh, so we don't know the first or the second one. Should be used to make 100 gallons of antifreeze. So what I do know is that there's 100 gallons of the antifreeze. So then, how are we going to do this? Well, we can only have one variable, and the reason why we can only have one variable is because that's all we know right now. Down the line, we're going to go over systems of equations, and if you have two unknowns, we could use two different variables. So that'll have to wait till later. So one of them gets to be x. So how would I get 100 when I have x and another amount? Oh, the x plus the other amount has to equal 100. So if I take 100 and I subtract the amount of the 40%, that's going to give me what I need. Okay, so what do I have? I have 0.4x. I have 0.6 times the quantity, 100 minus x. And then I have 0.48 times 100. Okay, now 0.48 times 100, that's easy. That's just going to give me 48. So I'm going to write myself a little note here. If you know the total, so that's going to be the final one, is going to be the total amount. The two unknowns will be x and total minus x. Okay, so that's going to be a pattern that you can use every time. All right, so again, I'm going to steal from exactly where I was before. Let's grab... Why I struggle on colored choices, I don't know. We'll just grab this guy. So then we write our equation, 0.4x plus 0.6 times the quantity, 100 minus x equals 48. Okay. I really don't like dealing with those decimals, so we're going to go ahead and eliminate them. So I only have one digit after the decimal point, so I'm going to multiply each of my terms by 100. That's going to give me 4x plus 6 times the quantity, 100 minus x, equals 480. So notice I didn't want to distribute first. Not this time. So now I'm going to go ahead and distribute. So that gives me 4x plus, and we're going to multiply 6 times 100, which is 600. And then we're going to multiply 6 times negative x, which is going to give me negative 6x equals 480, sorry. I do have like terms, so I am going to combine them. So that gives me negative 2x plus 600 equals 480. And then I am going to subtract 600 from both sides. So I'm going to put it on top to make the math a little simpler for me. He's gone. I get negative 2x equals, bigger number here is negative. I'm going to have to do a lot of renaming. Oh, no, I didn't need to go that far. Let's try that again. I can do 0, take away 0 is 0. It's only this far I need to go. 10 take away 8 is 2. 5 take away 1 is 4. Divide both sides by negative 2. So again, if I get a negative answer, I know I've done something wrong. 2 negatives make a positive. 2 goes into 12 6 times evenly, and there's a leftover 0. Okay, now this one's interesting because I need to give 2 parts to my answer because it asked for how much of each kind. So I have to distinguish one from the other. So this is how I would say 60 gallons goes with X, and X is the 40% glycol. So 60% or 60 gallons of 40% glycol. Oops, I don't know where that S came from. Needs to be mixed with and then this is where we're going to have to do a little bit of calculation. So we have 100 minus 60 equals 40. So 60 gallons of 40% glycol needs to be mixed with 40 gallons of 60% glycol to make, oh, wrong 2, 100 gallons of 48% glycol. Okay, now, some of you might go, oh, that's kind of weird. 60% of 40, 40% of 60, or 40 gallons of 60%. So do I just swap the numbers around when I do this math? No, this is a numbers game and it just worked out this way. All right, that's all I got for you guys. Good luck with this and we'll talk about it when we come back from vacation. Bye now.